Hi all, welcome to E-Content Development Center, Malabar College of Advanced Studies, Vengara. Myself, Shabeer Thiruvakkalathil, Assistant Professor, Department of Electronics, Malabar College of Advanced Studies, Vengara. Today, we are dealing with the topic transistors. It is a very important topic that comes under the Basic Electronics and Network Theorems course for the first semester BSc Electronics program offered by the University of Calicut. These are the learning outcomes of the session. By the end of this session, students will be able to recognize the history and importance of the transistor, to classify the types of the transistor, to discuss the structure of the transistor, to illustrate the configurations of transistor connections, to describe the applications of the transistor. Even though the concept of transistor had been there since the beginning of the 20th century, it was not possible to construct a working model. The first kind of working transistor was built in 1948 by three scientists at Bell Laboratories, United States of America. The scientists are William Shockley, John Bardeen, and Walter Brattain. These three scientists shared the Nobel Prize in Physics for this remarkable achievement in 1956. The invention of the transistor revolutionized the world of electronics tremendously. It became the key active component in most of the old electronic components in the present world. Hence, many of us consider transistor to be the most important invention of the 20th century. Before transistors, electronic components were composed of vacuum tubes. Vacuum tubes were bulky and unreliable. The first general purpose and programmable digital computer made in 1945, its name is ENIAC. ENIAC means Electronic Numerical Integrator and Computer, tells us the story of disadvantages that has been caused by the vacuum tubes. This particular ENIAC composed of 18,000 vacuum tubes. The space occupied by the ENIAC is almost 1,800 square feet. It is almost equal to the size of a large house in nowadays. So vacuum tubes are bulky. They are not only bulky but also not suitable for the portable products. Their operating voltages are very high. So the transistors made up of semiconductors, by replacing vacuum tubes with transistor, the computers could now perform the same function with less usage of power and space. Transistors are very small and less expensive when comparing with the vacuum tubes. Also, the transistors can combine in millions on a cheap die to make an integrated circuit. Simply, the invention of transistor led the world into modern computer or internet era. It opened the door to digital future. Definitely, we can say that transistors are the wonder child of electronics. The main activities offered by the transistor is amplification and switching of the electrical signals. Now, let us move on to the classification of transistor. Actually, in many ways, we can classify the transistors. In this session, our focus is on the classification based on the nature of the control signals. Here, two types are there. First one is BJT. BJT means bipolar junction transistors. Here, the input control signal will be in the form of current. In the second type, that is FET, that is field effect transistor. Here, the input control signal will be in the form of electric field or voltage. So FETs are generally known as voltage control transistor, whereas BJTs are known as current control transistor. Again, BJT can be subclassified into two, PNP and NPN. This particular classification is completely based on the nature of the semiconductor material. In PNP transistor, there are two positively doped semiconductor parts and one negatively doped semiconductor part. In NPN, there are two negatively doped semiconductor parts and one positively doped semiconductor parts. In case of FET subclassification, there are two types, that is JFET. JFET means junction field effect transistor. MOSFET means metal oxide semiconductor field effect transistor. This particular classification is absolutely based on the nature of the control terminal, that is gate. In JFET, there is a junction at the gate terminal, so the name junction field effect transistor. As far as MOSFET is concerned, there is a metal oxide insulator layer at gate, so the name MOSFET. In this particular session, we are focusing on BJT part, BJT classification and its explanation. But in case of FET, the discussion will be carried out in the later sessions. Okay. Here, this is the structure of bipolar junction transistor. In the left side, it is the structure of NPN transistor, and on the right side, it is the structure of PNP transistor. From the figure itself, you can see that there are three regions in a transistor. That is the collector region, base region, and emitter region. The base region generally acting as a control region. Actually, corresponding to these three regions, there are three terminals also. Their names are collector terminal, base terminal, and emitter terminal. From the figure, you can see that both the collector and emitter are negatively doped semiconductors. Hence, it is denoted as N. But in case of base, the doping is positively typed. Okay. Then, in terms of the doping concentration, we can say that the doping concentration of base is the least. Also, the doping concentration of emitter is the largest. That of the collector region is moderate. When we talk about the size of the three regions, again, base region having least size and collector region having largest size. The size of the emitter region is moderate. Also, from the figure, you can see that there are two junctions. In between base and collector, there is base collector junction, and in between base and emitter, it is base emitter junction. Exactly similar things are here at PNP transistor also. But the difference is that here the collector and emitter are positively doped, whereas the base is negatively doped. Now, let us move on to the symbols. Actually, symbols are used for drawing the circuit diagram. On the left side, it is the symbol of PNP transistor. On the right side, it is the symbol of NPN transistor. Both looks almost same, but there is some differences. In the symbol, you can see a separate terminal as base, but the collector and emitter terminals are almost looks alike. We can differentiate emitter terminal from the arrow mark, and we can also differentiate the symbols of PNP and NPN from the direction of arrow mark. In case of PNP transistor, the arrow mark is inward, but in case of NPN transistor, it is outward. This direction is actually analogous to the direction of current in the transistors. Now, we move on to the configuration. Configuration means how we connect the transistors in circuits. Basically, there are three models. One is common base, second one is common emitter, and third one is common collector. From the name itself, common base means base terminal is common to both input and output. We know that for every circuit, there should have an input section and output section. To the input section, we will apply the input signal and we take the response or output from the output terminal. In case of common base configuration, we apply our input between terminals emitter and base, and we take the corresponding output from terminals collector and base. So the base is common to both input and output, hence the name common base configuration. In common emitter configuration, emitter is common to both input and output. That is, the input is applied between base and emitter and the output is taken from collector and emitter. In case of common collector, collector is common to both input and output. Okay. Now, applications of the transistors. There are so many applications for the transistor. There are amplifiers, oscillators, switches, phones, integrated circuits, computer processors, radars, radios. From this list, we can easily say that we can't even think about an electronic circuit without the presence of transistor. Almost all of the electronic devices we are using in present world are having many transistors. So definitely we can say that transistor is the wonder child of the electronics. So we are going to conclude this session. Let us have again a look on the key points that we have been discussed so far. We had discussed the history and importance of the transistors. We had discussed the types of the transistor and we discussed the structure and symbol of the transistor. We discussed the configurations of transistor connections and finally we mentioned about the applications of the transistor. This is actually a brief introduction about the transistor. In the coming classes, we will focus on the working of the transistor and how the circuits can be made in different configurations, etc. So, we are going to wind up this session. Thank you. See you